let's look at another example. Maximizing the area enclosed by a fence. A farmer has 1,600 yards of fence to enclose a rectangular field. What are the dimensions of the rectangular that encloses the most area? All right, let's draw a rectangular, okay, just for you to visualize. So rectangle, we can denote this is the length, this is the width, right? And then the two lengths are the same, two widths are the same. So given the fence is total 1,600 yards long, so that means twice of the length plus twice of the width equals 1,600. So 1,600 actually is the perimeter, right? So we notice they all are even numbers, so we can cancel 2 out. So we have L plus W equals 800. And then we can represent L equals 800 subtract W, right? And then area function, okay, if we only want to represent in terms of W, and then that equals length times width, right? But length, we don't want to show another variable, so instead we use 800 minus W to represent L, because that's equivalent, right? Times another W, so we got a quadratic function, negative W squared, right? That's this term, plus 800W. Okay, distributive property, I just switched the order of the two terms in order to write in quadratic function in standard form. So in this quadratic function, we can easily identify A equals 91, B equals 800, C equals 0, right? And then if we want to solve this quadratic function, we can simply factor negative W out, and then we got W minus 800, right? We factor negative W out, so remaining factor will be W minus 800. So if we want to solve this function, okay, what let area equal to 0. So if we solve negative W times W minus 800 equals 0, we're trying to find the x-intercept, okay, and then we can use the zero product rule, right? Either W must equal to 0 or W minus 800 must equal to 0. That's derived to W equals 800. So we have two x-intercept. One is 0, 0. The other one is 0, 800. Right? All right, and then in this quadratic function, what about, okay, let me rewrite again. A over W equals negative W squared plus 800W, right? So we want to find a vertex, okay, which is x coordinates of vertex, H equals negative B over 2A, right? That's negative B equals 800 divided by 2 times A equals 91. So negative cancel out, and then 800 divided by 2, I got a 400. Okay, so the x-coordinates of the vertex is 400. And then because leading coefficient A is a negative number, so we basically know parallel open downwards, right? So we can find a vertex, okay, which is the highest point, right? We want to maximizing the area, so the vertex is what we're looking for, right? And the x-coordinates equals 400. And what about y-coordinate? So here I got a 400, and then we're looking for y-coordinates of vertex, okay? And then k will equals, evaluate this function, okay? Area of W function, replace W by 400. Okay, that's given us what? That's equals negative 400 squared plus 800 times 400. All right, it's right here. I don't have enough space. You evaluate this, and then I got the y-intercept is equals 160,000. Okay, you can try negative 400 squared plus 800 times 400. You should get 160,000. So this is the vertex, okay, with coordinates 400, 160,000. So what that means? That means the dimension of this rectangular garden or whatever yard, the width should equals 400, and the length is also 800 minus 400 also equals 400. So actually this is a square, okay? When the fence, make it as a square, and then it maximize the area, okay? So that rectangle enclose the most area. Okay, so we use quadratic function to solve this application problem. And the process you can watch. Okay, first we list the equation to represent a rectangular garden's parameter. And then area of the rectangle is length times width, right? So book use W represent the width, use X represent the length. So the width equals 800 minus X. And then substitute the width by 800 minus X, and then got a quadratic function. Okay, pretty much the same, right, as mine, only the variable name used different. I used the W, and this one used X. And then we got a quadratic function, and then we can identify ABC value, right? And then we can find a vertex. We find a 2x intercept, so we can graph. Right, earlier we got the same, right? 2x intercept, one is 0, 0, one is 800, 0. And then the vertex x coordinates is 400, right? Y coordinates, you plug it in, you got 160,000. Okay, so vertex is the maximum point on the graph of A, and then the maximum value occurs as when x equals 400. So that rectangle actually is a square. Okay, 400 times 400. That covers the most area. Okay, so we apply the property of quadratic function, which is the vertex, right? Maximize the quadratic function. So if we can find a vertex of quadratic function, and then we actually maximize the function.